We will now be solving the derivatives using the first principle. So suppose you have the function f of x equals to 2x squared plus 3x. So we will use the first derivative, the first principle, to derive this function f of x. We know that the formula for the first derivative, f prime equals to the limit of h as h approaches 0 of the function, the limit of the function f of x plus h minus f of x divided by h. So the limit of this function f of x plus h minus f of x over h as h approaches 0. So we first need to find the limit or the function f of x plus h. So we first have to find this. So meaning where there is x here, we will put f of x plus h. So the function f of x plus h is 2x plus h squared plus 3x plus h, x plus h, and then this gives us 2. Now this bracket here will be x squared plus 2xh plus h squared plus, now we solve this part here, 3x plus h. So now we distribute the brackets. We have 2x squared plus 4xh plus 2h squared plus 3x plus 3h. So now we do have the function f of x plus h. So we can now take this guy and we plug it over there at f of x plus h with this limit. So we have f of prime of x equals to the limit as h approaches to 0 of f of x plus h, but we already have f of x plus h, so we'll put that in, 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus the function f of x. So we're minusing the original f of x that we have, which is 2x squared. Because of the minus, we'll change signs for both terms, so we now have 3x over h. So now we can see that we still have a function of x, this x here, 2x squared and the minus 2x squared. So these, they cancel out. And then here we have a plus 3x with the minus 3x. So what happens? Those cancel out. what do we have left now? We still have the limit as h approaches 0 of what we have left. We have these terms left now on top. 4x h plus 2h squared plus 3h over h. So let's take h as a common factor, because we see we have all terms have an h in it on the numerator. So we continue to have the limit as h approaches 0 of the function. So we're taking out the common factor h now. So for this guy we have 4x plus 2h, because when you take one h out we left with 1, plus 3 all over h. Remember, the whole time we're doing this, we're just trying to make sure that as h approaches 0, we don't divide by a 0. Should we put a 0 here? So this now then cancels off. Now you have a limit as h approaches 0 of the function 4x plus 2h plus 3. So can we now put 0 without making this undefined? Yes, we can. Because now we can put 0 with this h. 4x plus 2, 0 plus 3. What is 2 times 0? 2 times 0 is 0. So we are left with 4x plus 3. This is the derivative of f of x. Perhaps we can just put this if we were derivative f prime of x, f prime of x. So the answer using first principle. So when you derive the function 2x squared plus 3x using the first principle, this is the answer you get. Or perhaps you will get the same answer depending on which one you're using. But using the first principle, this is how you solve it. Thank you. See you in the next video.